Alright, and welcome to part 2 of my jet tutorial. In the last one, we got pretty much everything set up that we need to get set up, and in this tutorial, we'll be actually writing the code, and it should be pretty easy since we did so much setup last time. Alright, so let's start inside of the event graph, and inside of the begin play. So this event gets called when when the jet is spawned inside of the world. So the very first thing we want to do is we want to set its current speed to something other than 0 so that when the game starts, it's actually flying through the air. So what I'm going to do is I'm going to take this min thrust to not fall, which again, this variable just represents the minimum speed that the plane must be going so that it doesn't have any sort of fall applied to it. And this is a good this is a good value to start the plane at because it's not too fast, but it's also not slow enough that you're falling out of the sky. So we're going to take this variable and we're going to set our thrust speed to that value. And we're also going to set our current speed, so drag in current speed as well. And again, the difference between thrust speed and current speed is just that the thrust speed is the speed that the thrusters want us to go, but the current speed is our actual speed. And then also to the right of this, once we get to the particle effects, we'll be creating the particle effects, but I'm going to leave that empty for right now because again, I want to save that till the end. All right, so that's really all we need to do inside of begin play. It's pretty simple. We don't need this begin overlap, so we can go ahead and delete that, but we do want to keep this event tick. So let's drag this up a little bit. So inside of here, we're going to do 3 things. We're going to first update the position, and we already have that function written, so we can just drag it in, update position, and it wants the delta time, which we have right there. And then the next thing we're going to want to do is, oh, I forget. The next thing we're going to do is update the thruster particle effects, but again, saving that till the end, so we're going to skip that. And then finally, we want to print out the debug variables just to kind of help us out to see what's going on. So that's our event tick. So let's go ahead and we'll write this function first since it's going to be really simple, the print debug variables, and we also will want to have it at the beginning. So there's really only 3 variables we're going to print here that I think are useful. We can print out others, but I think these 3 are the most important. So I'm going to hold down S and then left click to create a sequence. You can also create that by right clicking and searching for sequence and create it that way. And then we're going to hit this add pin so that we have 3 of them because we're going to be printing out 3 things. And the 3 things we're going to be printing out are the thrust speed, the current speed, and the applied gravity. So these variables, I'm just printing these out to give you guys a good idea of what's going on at runtime. So to do that, we're just going to say print string, and I'm going to hit this drop down and change the duration to 0 so that it only prints out for 1 frame since we're going to be calling this inside of the tick. And then if you drag off of this and search for append, we'll get this little append node. And so we can type the name of it. So we'll say thrust speed :space, and then we will append our thrust speed to that. And so that's one of the things we want to print, and we can just hit this little arrow to kind of collapse it again. And then we can just copy these 3 nodes twice. So that one and that one. And we'll drag that into here, and we'll drag that into here. And of course, for this, we want the current speed. And for this, we want the applied gravity. And we'll call this current speed and applied gravity. And just make sure I have spaces. I do. Okay. So if we go ahead and rerun this now, you should see that these values print out. Come on, save. I think it takes forever to save because I have such a large map. I'm not sure though. But I think that's the reason. I made a really large map so I'd have a lot of room to fly around. So if we press play, you can see up here in the top left, it's printing out our applied gravity is 0, our current speed is 4,000, and our thrust speed is 4,000. But again, we're not actually moving the plane yet, but once we start moving it and adding an input, then you'll see these numbers start to change and they'll kind of help you understand like why the plane is doing what it's doing. Okay, so back inside the event graph, we can come back here to the update position and we can start writing the actual logic to move the plane. So inside of here, the first thing we're going to want to do is calculate the current speed that we want the plane to be going. So ultimately, we're going to be setting the current speed. So I'm just going to go ahead and drag in the current speed and say set. So we're going to be doing some math, and then we're going to be setting this value. So kind of the way we want this to work is we want to interpolate between the current speed and the thrust speed based on the delta time. And if you think about it, we only want to do this if the plane is slowing down, because when you first, if you're speeding up a plane, like you're turning on the jets, the plane is going to accelerate pretty much right away. But if you turn off the jets, the plane is not going to stop right away. It's going to slow down over time. So we want to write some logic here that says, if the thrust speed is less than the current speed, then we want to interpolate to it. But if the thrust speed is greater than our current speed, then we want to just immediately update our speed. So to do that, we're going to say, drag in our thrust speed, and we'll say, hey, is the thrust speed less than our current speed? And then we'll drag off of this and make a select node. And if it's false, then like I said, we just want to go ahead and use the thrust speed because we're speeding up. But if it's true, then that means we're slowing down. So we want to interpolate to it. So we're going to search for f interp2, and we're going to hook the result up to our true. And we want to interpolate between our current speed and our thrust speed. And the delta seconds is going to be our delta seconds from up here. So you can either drag it down, but I like to just right click and say get delta seconds. I think it's a little bit cleaner. And the interpolation speed is going to be our drag, because this is kind of simulating our air resistance. And so this is going to calculate our current speed for us. So we can just go ahead and hook up our current speed. So that is the first thing we're going to do. And I'm just going to add a little comment around this to say calculate current speed. So this is the speed we're actually going to be moving at the end of this function. And the next thing we're going to do is calculate our new position, because we know where we are and we know the speed that we're moving at, so we can easily calculate our new position. So to do that, we're going to take our current speed, which is this guy, and I'm just going to say get current speed, and we're going to multiply it by delta time, so we'll say float times, and we want the get delta seconds, like so. And then we want to multiply the plane's forward vector by this amount, because this is essentially its change in position. So we want to move it that much in the direction that it's going. So we'll say get actor forward vector, which is just the direction our plane is facing, and we'll say float multiply. So we'll multiply that value by this value, and that's going to be our new position. So I'm just going to right click on this and promote it to a local variable. And now we'll create a variable down here, and I'm just going to call it new position, just to kind of keep things clean. And we can hook that up like that. So I'm just going to add a little comment around this and kind of say calculate new position based on current speed. And then after that, we want to check if any gravity should be applied. And I know that terminology might be a little confusing because I know gravity is technically always applied to an airplane, but we're kind of doing some little magic here, and not really magic, but some game magic, I guess. And we're saying that gravity is only applied if the plane's moving really slow, because in reality, the plane wouldn't actually be being pulled down by gravity if it's moving fast. I mean, I know it's still being pulled down, but hopefully people don't think I'm stupid. We're just saying that the plane shouldn't be actively falling if it's moving fast, because in reality, lift would be lifting up the plane from the wings. So that's what our applied gravity is going to be, is how much gravity is actually pulling, how much it's actually affecting the plane. So we want to calculate our applied gravity. So to do that, we're going to drag in our applied gravity, because we're going to be setting that. And again, we want to set that value using this value that I talked about at the beginning, the min thrust to not fall. And again, if you forget what this is, this value just represents the minimum speed that the plane must be moving at to not start falling out of the sky, or to not start, I won't say falling out of the sky, but to not have any gravity applied to it, more or less, if you want to think about it that way. So we're going to take our current speed, and we want to, if you search for map range clamped, we want to map our current speed. I don't know how to explain this too well. We basically want to take, let me hook it up first, and then I'll explain it, because I can explain it better if I'm looking at it. So we want to hook up the min thrust not to fall into our in range B, and we want to hook up gravity into in range A. So basically what this is doing is it's taking our current speed and it's mapping it between A and B. So it's mapping it between 0 and our min thrust not to fall. So this is like 4,000, I think. Yeah, so it's saying if the current speed is 0, then use 100% of gravity. If the current speed is the min thrust not to fall speed, which is 4,000, then use 0. And if the current speed is greater than this min speed, it's also going to use 0 as well. So it's basically just saying, hey, if the plane is going faster than our min thrust not to fall speed, then don't apply any gravity. But if it's slower than that speed, apply a certain amount of gravity. So if it's, half that speed, we'll apply half gravity. So that kind of makes it so that it slowly starts to fall out of the sky as you slow down. And then once you're totally stopped moving, then full gravity is applied. So hopefully that makes sense. So we just want to go ahead and hook that up to our applied gravity and hook that up like so. And then we can add a comment around this that says calculate applied gravity. And then finally, we want to update the actual position because we have this new position variable. We just need to kind of apply the gravity to it and then set it. So to do that, we're going to take this new position variable over here. So let's just go ahead and drag this in and say get. And we want to split this because we want to apply gravity to it, the applied gravity that we just calculated. So we'll say break. And then we'll say make vector because we're going to recombine it again here at the end. And the x and the y are not going to change because, again, we're only going to be applying gravity right here. But the z value, which is the up and the down, we want to change this based on whatever this applied gravity is. So we want to say float minus because we're going to be, the gravity is down, right? So float minus the applied gravity times delta time, or delta seconds, like so. And hook that up. And hook that up. So that's basically just going to pull down the plane however, by however much we calculated before. And then finally, we can say set actor location, or sorry, not that, add actor world offset. And this is what's actually going to move the plane. So the delta position is that, or the delta location is that, and make sure you hook it up like so. And you can probably turn on sweep if you want. That'll just make it so that it makes it so it can't go through things. And then make a little comment on this and say update position. All right, so if all is well, then it should fly when we run it now, although we won't have any control over it. Let me just go ahead and make sure we save this. I just like to save things because sometimes Unreal just kind of crashes on you. And then you lose all your work. So give it a second here to save. Okay, so if we press play, perfect. You can see the plane is flying through the air, and our current speed is 4,000, our thrust speed is 4,000, and our applied gravity is 0 because it's saying, hey, you're flying 4,000 units a second or whatever, and that is the minimum required speed for you not to fall, so it's not applying any gravity. And you'll see once we add in the ability to change the speed, you'll see once we get below this 4,000, the applied gravity will start to go up. But for now, we're just essentially flying in a straight line. All right, so that is our position being updated. So we'll just file and save all this again, even though I just saved it. I don't know why I did that, because it takes forever to save it. I gotta stop doing that. I have a habit of just file, save all the time. All right, so once this saves, we're gonna go back to the event graph. Actually, we should probably add in our input keys next, since we want to start adding input. So come up here to the edit project settings, and then on the left, go to input. And we want to add some axis mappings. So hit the little plus button right here, and then drop this down. So we want to add 4. We want to add 1 for the thrust, which is the speed of the plane, basically, and then 1 for the yaw, 1 for the roll, and 1 for the pitch. So say thrust. And again, you can use whatever controls you want for this. I kind of copied Battlefront controls, I think, according to Google. So I'm saying W is thrust forward. So make sure you set W and then a scale of 1. And then to go backwards, we can add another key, S, on the keyboard. And make sure you set the scale to -1. So W is set to +1, S is set to -1. And then we want another one for y'all. So click the plus and say y'all. And for y'all, we're going to be using the D key and the A key. So search for D. And D should be +1. And then A should be -1. So add A and make sure you say -1. It's very important you get these scales correct, otherwise it won't quite work. And then we want another one for pitch. So search for pitch. And the pitch we're going to actually tie to the mouse. So we'll say mouse Y. And I'm going to set this to -1. Now, some people are used to inverted versions of this. Like some people like the mouse to go up to move the plane down, and some like the mouse go up to move the plane up. So you might, if it's backwards to you, then just change this to a +1. But I'm used to it being this way, so I'm going to set it to -1. And then finally is the roll, which is going to be controlled by the mouse X. And I think that is pretty universally just +1 here. Okay, so now we have all of our inputs defined, so we can go back to our event graph and actually start listening for those events. So the first one we'll do, since it's probably the easiest, and I'm going to resist the urge to save all again, is go back to the event graph. Our event tick got kind of messed up. Okay, so down here we'll say event thrust. So this is going to get called every frame basically, and it's going to give us the value of W or S. So we're holding down W, then axis value is going to be 1. If we're holding down S, it's going to be -1. If you have this hooked up to a controller with a joystick, then this value will be anywhere between -1 and +1, depending on how much you're pressing the forward on the joystick. Okay, so inside of here, we want to update our thrust speed. And to do that, we are going to make use of this, where is it? Thrust multiplier. So we want to take the axis value and say float multiply. And we want to multiply it by two things, so add this pin twice. We want to multiply it by the delta time, so get world delta seconds. And then we also want to multiply it by our thrust multiplier. And again, you can change this value. I have it set to 2500 right now, but this is essentially how fast you can speed up the plane. And then we're going to take that and we're going to add it to our thrust speed, our current thrust speed. So say float plus and give it the thrust speed. And then we want to set our thrust speed to that value. But before we do that, we want to make sure that our thrust speed does not go above our max thrust speed. So there's a handy little function for that called float clamp. And so we'll hook up that. So the min value is going to be 0 because 0 is the minimum thrust speed. If you turn off the engine, then there's going to be 0 thrust. But our max is going to be our max thrust speed, like so. So hook up the max and hook that up. Okay, so now our thrust speed should be changing. And I'm going to save it. I know it takes forever, but I'm going to do it just in case it crashes. And then now once we run this, once it finishes saving, we should be able to speed up and slow down, and you should be seeing the gravity being applied once we get below a certain value. And you should also see the current speed updating correctly. So if you go ahead and run it, and you hold down W, you'll see the current speed and the thrust speed go up together. You can see now they're both at 10,000. But if I start slowing down by holding down S, you'll see the current speed lags behind the thrust speed, and that's because we're simulating drag. We're simulating that, you turned off the thrusters or you're slowing down the thrusters, and so the airplane is slowly slowing down over time. And I'm going to run it one more time. The other thing you'll notice is I'm just going to press S for like a split second here. Let me click the window. So I pressed S. So you can see the applied gravity is now at 30, and it will eventually level out to like 40 or something. But you can see we're very slowly having gravity applied. We're very slowly being pulled down because we're not quite going fast enough yet to not have any fall on the plane. And you can see the more we slow down, the more that gravity applied gets set, or the more gravity gets applied essentially. And that's what we did inside of the update position. But I just kind of wanted to show you that so you could see how the algorithm is working. Okay, so the next thing we need to do is make it so that we can actually turn. So right click and search for event yaw. And let's just go ahead and call our update yaw function that we've already defined. The yaw is going to be our access value, and our delta seconds is going to be our get world delta seconds. So I'm just going to copy and paste that and hook that up. All right, so let's actually go inside of here and define it. So double click on it. So the first thing we're going to do is set our target yaw to whatever yaw is being passed in. So drag in target yaw and set it. And again, this is our target yaw. This is the yaw we are trying to achieve, but that doesn't mean the plane's going to instantly yaw to that amount. We're going to interpolate to it over time. But we want to know what our target is so that we can have something to move towards. So we're going to set our target yaw right away, and then we're going to set our current yaw based off of that. So drag in the current, oops, that's not it, current yaw. Drag in the current yaw, and we're going to use this handy function called finterp2, which stands for interpolate to. And so we want to interpolate from our current yaw. So again, we'll drag in our current yaw to our target, and our target is going to be our target yaw. The delta time is going to be our delta seconds. So say get delta seconds, hook that up. And our interp speed, you can set this to whatever you want. I'm just using 10. You could also make this a constant variable over here, but I just never did that because I don't know why, but I just didn't. But this is essentially, how fast your plane can rotate. But I found 10 to be a pretty good value. And so we'll hook that up to our current yaw. Now that we know what we want our current yaw to be, we actually need to rotate in that direction. So we'll say add actor local rotation. And the rotation, we want to split this delta roll, or delta rotation, and we want to set it to our current rotation, our current yaw times, oops, not that, float times the delta seconds again, so just copy this guy, and then some multiplier to speed it up a little bit. Again, you can make this variable, you can make this a constant variable if you want, and you can change it to whatever you want, but it's just to make it rotate a little bit faster than it would normally without it. And we want to hook that up to our yaw. And then finally, we want to actually rotate the flaps themselves. But before we do that, we can actually probably just go ahead and run this to test it real quick. So we press play, and we press A or D. Why did that not play? So you can see when I press A and when I press D, the plane is yawing from left to right. And so again, you can change these values and see what they do. If I set up to 100, you'll see it just turns a lot faster. So it's just kind of whatever feels good for your game. Feel free to change those values. Okay, so finally we want to rotate the, I think it's the rudders. Yes, we want to rotate the rudders, which are these guys in the back, which you can't see in this model, but the ones that go right here. So to do that, back in here, we'll drag in our rudder. So we want to do both of them. So we're going to drag in rudder L, and we're also going to drag in rudder L, and we're also going to drag in rudder R. And then we're going to say set relative rotation. So we're going to hook this up. And the rotation we want to set it to is going to be based off of our current yaw value, but we want it to be between our max rudder yaw, which we have already defined down here, and it's set to 45. So we want it to be between negative 45 and positive 45, depending on what our current yaw is. So we're going to use that map range clamped function again. So search for map range clamped, and go ahead and split this rotation because we only want to affect the yaw. So we'll hook up that. Move this over a little bit. So the value that we're basing it on, again, is our current yaw. So we'll drag in our current yaw. That up. The min value is going to be, or like the range A value is going to be -1, and range B is going to be +1, and then the out range A is going to be our max rudder yaw. So let's see, max rudder yaw, drag this in, that's our A. And then our outrange B is going to be the negative max rudder yaw. Now I'm just going to go ahead and create a little macro for this to make this a little bit easier for us. And we will just call this macro negate float. And all it's going to do is take in a float multiply, take in one of these, multiply it by -1, and return that value. And I'm just going to call this out. I'm going to call this in. This will just make the code a little bit cleaner. So back inside of the update yaw, we're going to copy the max rudder yaw, and we'll say negate float. And there's actually, you see, there's actually this utilities one, which is, oh, that's the one I created. But there's actually one that Unreal defines, if I can find it. Yeah, this one, but it requires these execution pins, which is kind of ugly, and I hate it. So we're not going to use that. We're going to use ours, so that we can just do it like this. So it's basically just taking the negative value of this. So just to kind of summarize, what this is doing is it's saying, let me look at the current yaw, and again, this value is going to be between -1 and +1. And it's saying, okay, if it's -1, use this value, which is 45. If it's +1, use this value, which is -45. And if it's somewhere between there, like say it's 0, then it's going to use halfway between -45 and +45, which is 0. But if it's, some arbitrary number like 0.27, then it's going to be using, 0.27 of this -45. So it's a nice interpolation between -1 and +1, and it converts that to be a value between -45 and +45. Okay, and we want to do the same thing for rudder R, so I'm just going to copy all of this, not this, and not this. Copy these values, oops, and paste. And put this up. Our target is going to be our rudder R. And yeah, that actually looks good. Actually, I guess we don't need to do this twice. We can probably just delete this and hook this up now that I look at it. That's probably a smarter idea. Okay, so if we go ahead and rerun this now, and why did it hide it? So when I go left, you'll see the flaps rotate in the correct direction. I'm pretty sure that's the correct direction. Yeah, because the flaps go left and it pushes it. Yeah. If I have one of these flaps backwards, I apologize. But again, I'm not a plane guy, so I'm doing the best I can. But this is basically how the flaps work. You can see they kind of rotate the tail of the plane and have it. That's what controls the pitch of the plane. All right, so those are our rudders. So now we just kind of need to do the same type of logic for the other types of flaps as well, and then obviously rotating the plane. So the next function we're going to define here is, let's go back to the event graph. Let's see. Let's do the pitch. So we'll say input pitch, and we'll call our update pitch. Oops, that's not it. Update pitch. And our delta seconds will be our delta seconds, and our pitch will be our axis value. So this function is going to be pretty similar to this function. So I'm actually just going to go inside of this function that we just wrote and copy everything except for the function signature. So I'm just going to say copy, and then go into update pitch and paste. And we're going to just kind of update this to use our pitch instead of our yaw. So hook this pitch up. So now everything's kind of hooked up again. Don't worry about the compiler errors right now. So we want to change everywhere where it says yaw to pitch. So target pitch we want to replace, or sorry, target yaw we want to replace with the target pitch. So say target pitch, you can actually just drag and drop, and you can see it says change node to right target pitch. And then again, we have target yaw over here. So we'll say target pitch. And I believe that's the only place we use the target. Yes, it is. And then we also want to replace the current yaw with the current pitch. So we'll drag in the current pitch to there. And then it's also up here, so we'll say current pitch. And we also want to do it here, so we'll say current pitch. And that's it. And again, just kind of make sure you look over this and make sure everything says target pitch, current pitch, target pitch, current pitch, current pitch. Make sure nothing says y'all. And I think we are good. Well, we're almost good. So we need to come back here and we want to, I don't know why, but Unreal doesn't really recognize even though this parameter exists. So just delete it and search for it again, get delta seconds and hook it up to the delta time and do the same thing for this guy. And of course we're using pitch now, so we actually want to change this to be the pitch instead of the y'all. So hook that up to pitch. And we also want to do the same thing for these guys. We want to hook this up to the pitch and not the y'all. And the pitch and not the y'all, like so. And I believe that's all we need to do. Oh, no, we need to change this value. So we have the max rudder y'all. We actually want to change this to the, let me think here. We want to change this to the flap. So search for max flap pitch, because the flaps are what controls the pitch. So hook up the flaps. And then also the elevators. So I think technically the elevators don't, or I think the elevators are the things that control the pitch, and the flaps actually control the lift of the plane, but I'm not going to get into like super science physics stuff here. Again, this is not like a perfect military grade simulation of an airplane. This is just for games. So for this purpose, I'm going to adjust the pitch and the elevator together at the same time. So this is just doing the flaps. So we need to change this to flap, flap L, flap R. I'll go over this again once I get this one done because I know this one's a little bit confusing. So make sure you change this to flaps. And we also want to do the same thing for the elevators. So I'm just going to copy this stuff and paste it over here. Oops, I keep doing that. Paste it over here. And we want to change, instead of flap L, we want to say elevator L and elevator R. And we want to change this, instead of max flap pitch, to max elevator pitch. Oops, like that, and like that. And then I think we should be good. So if we go ahead and test this now, this will be the easiest way to see if you accidentally messed it up. If you run it and the flaps or the elevators don't move in the correct direction, then you probably just messed something up, which is very possible that I also did just now. We'll see real quick once it finishes saving. All right, so go ahead and run this. So if we pitch up and down, you'll see the two tail elevators in the back pitch. And also, if you can see kind of on the front wings, the inner flaps pitch as well. So those are the two things that I have controlling the pitch. And they pitch up when I go up, and they pitch down when I go down, which I think is correct. I believe it's correct. Again, I don't think it's exactly how planes work in regards to the flaps. I think they move a little bit different than that, but again, not making anything super serious here. Okay, so the final thing we have to do is the roll. So we'll go back to the event graph, and let's see, we'll say input roll. And this one's going to be a little bit different because they're not going to move in unison with each other like the other ones have. So we'll drag in our update roll and get Oriel delta seconds. Hook that up, and our roll is going to be our roll. So let me take a look at my other one real quick to make sure I can do this in a good way. Yeah, so what I'm going to do, again, let's go ahead and copy this y'all one again, since this one's actually pretty simple. Copy all this except for the function name. Go inside a roll, and let's just zoom out. Oops, I didn't actually copy it. Update y'all. Try this again, Control C. Update roll, paste. And we're just kind of going to do the same thing we did last time to save us some time. So we want to drag the roll into our target. And then we want to come in here and we want to change everywhere it says target y'all to target roll. So we'll say target roll. target roll, and that's the only place we're using target. And then current roll, current roll, current roll, and we're good. Then we need to do the delta seconds, so compile, get delta seconds, hook it up to delta time, replace this guy. Okay, so at this point we need to change it a little bit once again. So for the roll, we want to hook it up to the roll of the airplane so that it actually rolls it. And then over here, let's go ahead and separate this guy and move him over to the side for a second. So we don't want to change the rudder, we want to change the ailerons, I think. So replace this with the aileron. And this is going to be the current roll, except this we should want to be the max aileron pitch. So drag in the max aileron pitch and drag in the max aileron pitch. And I believe that is correct. Oh yeah, and this needs to go into pitch as well because we want this to pitch. And just delete that and copy this guy, paste him over here. And this is going to be aileron R, so drag in aileron R. All right, so we are almost done, except if we go ahead and rerun this now in pitch, or we try to roll, you'll notice something isn't quite right. So if I try to roll, you can see it rolls, but, well, actually a few things are happening. So if I'm looking at this outer left wing here, you see that one is pitching, but the one on the right isn't. And I believe, why is that not pitching? Oh, because I left this as elevator R. This needs to be aileron R. So let's try this again. So if we pitch, you can see, okay, so now it's doing what I would expect it to do, but you can see they're pitching in the same direction. But in reality, when you go left, the left one should go, this is always confusing to me. The left one should go up and the right one should go down. So to do that, we just need to reverse the left side here. So we want to change this to go down here and this to go up here. I think that is correct. So left, yes, I believe that is correct. Somebody can correct me if I'm wrong, but I believe that is correct. All right, so now we have our yaw, our pitch, and our roll all set up. And we can also accelerate and decelerate however we want. And so this is pretty much all the physics for the plane. Again, like I've been saying this whole time, this is no military simulation style of physics. This is not like scientifically accurate of how a plane flies, but it's definitely a really good starting point for any game that you're trying to make because like video games don't actually simulate lift and all that nonsense. They just kind of fake it like we're doing right here. So feel free to tweak these values as much as you want. In the next section of this video, I'm going to be showing you guys how to hook up the particle effect that comes out of the back of the plane for the thrusters. I'll just show you real quick again if you missed it in part 1. So this is my other project. Okay, apparently it's broken. Never mind, I won't show it to you. But I had thrusters that were coming out the back of the plane using Niagara particle effect system. So if you want to stick around for part 3, I'll be showing you guys how to create that particle effect from scratch and also how to hook it up so that it kind of gets bigger when you speed up and it gets smaller as you slow down. So if you don't want to stick around for that, just leave a like if you enjoyed the video and consider subscribing. And that's about it. See ya.